I'm going to do this quick review with you guys here. I know we didn't have time to finish it in class, but here is the review sheet I handed out in class, and I'm going to go through the answers right now in case we didn't get to them in your class period. So with this, a Foucault pendulum. Again, anything you ever need to know about a Foucault pendulum is it provides evidence of rotation. It doesn't matter if it's on the Earth, on the moon, or on Mars. If there's a Foucault pendulum in the question, it always has to do about rotation. The Coriolis effect is also evidence that the Earth is rotating. Remember, the Coriolis effect is the bending of the winds. Which way does the Earth rotation cause the winds and ocean currents to shift in both the northern and the southern hemisphere? If you remember when I first taught you about the Coriolis effect, I explained that it was Santa Claus delivering a present from the North Pole and shooting it down towards us. In the northern hemisphere, they always bend to the right. And I said the best way to remember that is we live in the northern hemisphere, so of course we're right. And I know that's a little goofy, but it's the easiest way to remember. And if they bend to the right in the northern hemisphere, they go to the left in the southern hemisphere. All right, so I would like you to label the times A, B, C, and D on the diagram. So what you can see here is this is looking down at the North Pole. You can see that it's cut perfectly in half by the night and the day right along the North Pole. So that means the sun must be coming from over here, which would make A, noon, C, directly opposite that would be midnight. Following them around, we have midnight going to noon. So if this is midnight, then it has to become day, which would be 6 a.m., noon, and then we are back down to 6 p.m. The length of day is based on one rotation. So remember, rotation is the day and the length of the year is one revolution. Do not get those two confused in your head. What are the rates of rotation and revolution? So rate is not how long it takes, but the rate is change over time. So remember, for rotation, the Earth spins 360 degrees. That's one full circle in 24 hours. That gives you 15 degrees per hour. For revolution, the Earth goes around the sun. That's approximately 360. Takes about 365 days for that to happen. 360 divided by 365 is about 1 degree per day. Again, you do need to know both of those. Why are different constellations visible from the night side of the Earth during different seasons? So we're not talking about just one night. We're talking about during different seasons. And that is, again, so seasons are due to the revolution. So I guess we should say the revolution of Earth around the sun. How about 3 facts about the geocentric? What is the center? Earth is the center. 3 facts. Everything So everything revolves around Earth. By everything, I mean the sun, the moon, the stars, the planets, everything. And this did explain night and day. Heliocentric is the sun is the center. So Earth goes around the sun. You could also add the planets go around the sun. Any of those are good. All right, the sun appears to rise in the east and move through, we just did this today, the southern part of the sky and sets in the west. At what time of day are the shadows the longest? So remember, it's longest when the sun is low in the sky. I'm gonna add that sun is low, but that doesn't answer the question. It wants the time of day. So morning and evening are when the sun is low in the sky. So when are they the shortest? Remember when the sun is high. And when is the sun high in the sky? That's around noon. On what date is the sun highest in the sky at noon? That's going to be the first day of summer. And yes, you do need to know that that happens on June 21st. So then what day are on what dates are the shadows the shortest? Again, because the shadows are short when the sun is high in the sky. Again, that's June 21st. Just want you to make that connection. When the sun is high in the sky, they're going to have short shadows. How about, let's keep going here. On what day is the sun lowest in the sky? That'll be the first day of winter. Again, that does not answer the question. So it says on what date? So that's December 21st. And again, what date are the shadows the longest? The shadows are the longest when the sun is low in the sky. So again, December 21st. On June 21st, where will the sun appear to rise and set as seen in New York State? So again, this was something we just did on June 21st. That's the first day of summer. They rise just like old people or just like birds. They come back north. So not just rises in the east, but it's going to rise in the northeast and not just set in the west. It's going to set in the northwest. So again, it's not just plain old rises in the east and sets in the west. You do have to adjust those for the time of year. Describe the changes in orbital speed and gravitational force as the planet moves from A to B and then back to A. So just remember, always moves fast, moves fastest when closer to the sun. So how I'm going to do that is when we go from A, here's where it's the closest. Again, here's the planet, there's the sun, so that's close. Here's where it's farthest away. So as it's going from A to B to C, it's going from close to far away, so it must be slowing down. And as we're going from B back over to A, we're getting closer, so it's speeding up. The force of gravity is greatest when their masses are great or large, I guess I should have said. And they are close to the object. So the closer and the bigger they are, the stronger the gravity. And again, remember, stronger gravity equals moving faster. On the back here, true or false, the sun is never directly overhead. So sun is never directly overhead in New York State. That is 100% true. Do not let them trick you. All right, they want to know which season is at the beginning of each one of these. So I always ask myself, which one is summer? And I know it's summer because the sun is leaning towards the sun or bowing. So this one over here is summer. I always then go directly opposite of summer is winter, and then double check your arrows. Summer, blank, winter, summer, fall, winter, spring. Always follow the arrows. The sun is directly overhead the equator on September 21st or 22nd in this case, and March 21st. The position of the sunrise and the sunset change with the seasons because the earth is tilted on its axis while it revolves around the sun. All right, now we're going to label the dates at each position. So again, which one is summer is the beginning? This one's going to be summer because it's leaning towards the sun. Again, they didn't say what season they wanted the dates. So summer is June 21st. Winter is December 21st. Spring is March 21st. And fall, this is not spring, sorry, June. Then fall, which is September 23rd. Don't fall for their tricks. And then this one is March. How much of the Arctic Circle and the North Pole are illuminated by sunlight on the first day of summer and on the first day of winter? So we can tell by looking at these pictures. Here's the first day of summer. There's the North Pole. The North Pole in the summer is getting 24 hours of daylight. But on the first day of winter, it gets 0 hours of daylight. According to the sketch, which latitude is receiving the most direct sunlight? Remember, direct sunlight means when it hits at a 90-degree angle. So if the sun's coming over here, that is not a 90-degree angle. If the sun's going over here, that is not a 90-degree angle. But, well, and it's not perfectly, but right there at 0 degrees, which is the equator, gets the most direct. It wasn't perfectly direct, but it is closest to 90 degree. Describe the length of daylight and night hours on both of the equinox. So remember, equinox stands for equator and equal. Equal hours of day and night. Calculate the eccentricity. Oops, gotta grab a ruler. Yes, you will need to be able to calculate eccentricity. So you take eccentricity is the distance between the two foci divided by the length of the major axis. So it looks like I have 2.5 divided by 4.5. Grab a calculator. So remember, the top number always goes into the calculator first. And that gives me 0.55555. And I'm going to tell you, you always need to round this to the nearest thousandth. That's 3 numbers after the decimal point. So I've got the third 5, and I have to decide, does that round up or stay the same? So I look over here, and then because it's 5, that rounds up. So we've got 0.556. Don't write any units on that, just a ratio, no label. Where is zenith? Vocab word, directly overhead. On March 21st, the sun rises exactly in the east and sets directly or exactly in the west. Remember, those are the only 2 days that happens. The sun follows old people. And by that, I mean in the summer, it rises in the northeast, sets in the northwest, and in winter, it goes down south, just like all those old people. So it rises in the southeast and sets in the southwest. The Earth's orbit is slightly elliptical, which again just means oval. Either answer would have been fine. In the southern hemisphere, in the summer, in the northern hemisphere occurs when the Earth is farthest away from the sun at aphelion. Why? Again, doesn't have to do with distance. It's just because that's when the northern hemisphere is leaning or is tilted towards the sun. As the planet gets farther from the sun, so as we get farther, its orbital velocity will slow down. All right, quick moon phases review on the diagram below. On the diagram below, circle the position of the moon where the solar eclipse will be possible. So remember, a solar eclipse is when the sun is getting blocked. So if we're on Earth, which one of these is the sun going to get perfectly blocked? It would be this one. Now on the diagram to the right, shade the portion of the moon that is in its dark, the moon that is darkness to show, sorry, on the diagram to the right, shade the portion of the moon that is in darkness to show the phase of the moon at position 3 as described from New York State. So if we wanted to look at position 3, remember, I always told you to turn the paper. So moon number 3 is at the top. Cover up the back half. When you cover up the back half, you ask, is it mostly light, mostly dark, or half and half? I see mostly light, so that's a gibbous, and the light is on the left, so it's a waning gibbous. So a waning gibbous will look like this, mostly light with the light on the left. Using the term rotation and revolution, explain why the same side of the moon always faces Earth. And that is because the moon rotates and revolves at the same speed. Explain why the moon's gravity has a greater effect on the Earth's ocean tides than the sun's gravity, and that's because the moon is closer. The table to the right shows the time of the ocean tides on March 4th for a city at the Atlantic coast of the United States. Determine when the next low tide occurred, include AM or PM. So we see that a high tide happened at noon, and then at 12:20, I'm sorry, at midnight, and then again at 12:26 in the afternoon. So they're about 12 hours apart. So this a little bit longer than 12 hours apart. It's almost 12 and a half. The last low tide happened at 6:13 a.m. Remember, they happen about every 12 and a half hours. So 12 hours later would be 6:13 p.m. Add about a half an hour to that, 6:43 p.m. They would have probably been okay with you going with 6:13 as well. And finally, the last page, the photograph to the right shows the phase of the moon observed from New York State. State the numbered position which the moon was located when this photograph was taken. So I'm seeing here, it's half the moon is lit up, which we know half of a half is a quarter. So this is a quarter and it's a waxing quarter. Now they want you to go up here and tell me which one's a waxing quarter. I can do this a couple different ways. I'm going to start with moon number 1. What is moon number 1? I look up, it's half and half with the light on the right. So all right after that, it's number 1. State the number of days the moon takes to go through one complete cycle from full moon to full moon. Remember, that's 29 and a half days. State the number position of the moon that could result in a lunar eclipse. So remember, the lunar eclipse is when the moon gets blocked. So if I'm standing here, I look over here, no, I can see the moon. But if I'm over here, I won't be able to see the moon because the Earth's shadow will be in the way in position 3. Lunar eclipse always happen on a full moon. That's another way of remembering. Explain why the moon's orbital velocity is slowest when the moon is farthest away. So remember, when it's closer equals stronger gravity. Remember, that means moving fast. So this opposite is true when it's far away. We have low gravity and we move slow. And the last question, we just did this one already. Explain how the moon's rotation and revolution caused the same side of the moon to always face Earth, because they happen at the same speed. We rotate and revolve at the same speed. So that was just a quick review, going over the review sheet you got in class. Make sure you bring all this stuff to class with you tomorrow for the Chapter 9 test.